Hello engineering students, Mr. O again. I'm going to go through a second example. Question number 3, to find the reactions for the supports on these simply supported beams. So I'm going to work straight away on question number 3, and I'm going to start with redrawing the diagram so I can understand it a little bit more clearly. So I have a beam. It is 2 plus 3, that's 5, 6, 7, 8 meters long. It has a fixed or pin support, and my drawing is not very straight at all. And on the other end I have another support, but it's a roller support. What that tells me straight away, I'm going to have a force vertical. So this is my reaction right. I'll try to make sure I do the right thing when I do that. And my reaction left. It should have, because it's a fixed and pin support, it should have a force upwards. I say I'm going to assume they're both positive. And it's going to have, because it's a fixed or pin support, it is going to have a force left horizontal and a force left vertical. This will have a force right vertical. Let me have a look at the forces that I have. 1 and 2. Okay, so 1 is a normal force perpendicular to the beam, which is in newtons, 300 newtons. The next one is at an angle of 60 degrees, and it is 400 newtons. Let me just work out my lengths. This is 2 meters away. Those are 3 meters between each of them, and this is 3 meters to the end there. So have a good idea. First things first, I'm going to do my assumptions. And I'm going to simplify these assumptions now. So I've not been told otherwise, so therefore this beam is in equilibrium. Therefore, the sum of all the moments will equal 0. My moments equals force times distance. And because of that, I will do a little diagram to show my clockwise moments are this way, and my counterclockwise moments are this way. Have a look at my previous videos to figure out how I get to that point. And I'll also then work out that my horizontal forces, sum of my forces vertical equals 0, and the sum of my forces horizontal equals 0, making that all my positive forces vertical will be will be positive, and all forces down will be negative. All my horizontal, did I say vertical? Yeah, my horizontal forces will be positive to the right and negative to the left. So those are my basic assumptions. My next thing I'm going to do now, I've noticed all my units are in meters and all my forces are in newtons. So I'm going to stick to being newtons. And I'm going to do a quick 1A solution, which is now, this is at an angle. So what I'm going to do is I'm going to resolve that to, because it's at 60, I automatically know that my force vertical is going to be greater than my force horizontal. And the likelihood that it's going to be down and to the right, because it's pointing in that general direction. This is 400 newtons. I'll solve this very quickly now. So my force vertical at that point will be hypotenuse times sine theta. My force horizontal will be hypotenuse cos theta. So force vertical is 400 times sine 60, which is, let me see what the calculator tells me it is, 400 sine 60, 346.41 newtons. Let's make sure it's not, we don't just suddenly start saying it's kilonewtons. Force horizontal is going to be less than that. So it's going to be 400, but cos 60. 400 cos 60, 200 newtons. And that's pretty simple to work that out. I haven't gone into the detail. I'll go into it very briefly now, because I have my hypotenuse This is my angle, this is my opposite, and this is my adjacent. Sine theta equals opposite over hypotenuse. I'm batting to right now. And if I want to find out what my hypotenuse is, I time through to that side. It becomes hypotenuse times sine theta equals opposite. And then I divide through and it becomes, I'm trying to find my opposite. So that's effectively what I've just done there. My FV is my opposite. If I was doing cos equals adjacent over hypotenuse. I've got the hypotenuse. I want to find out what the adjacent to that angle is. So I multiply that through. Hypotenuse times cos theta equals my adjacent value. So 400 times cos theta is my adjacent, which is my force horizontal. So technically, I've now got those two. Let us now do a moment calculation. We're still trying to find the reaction to those two, and we've got a downward force, 90 degrees, and we have now resolved these to both a, so what was that being 400 is now represented as a downward force, a vertical force of 346.41 and a horizontal force of 200 kilonewtons that way and that way. So we're going to go and create a moments calculation. So we first do moments and then we do forces up and down. Let's go from the left and simply from the fixed end. I mean, you can do it from that side as well, it doesn't really matter. But as long as we make all our distances from that point. So I have my beam acting like a seesaw, and I'm going to create a moment calculation around force left. Sum of my moments of the whole beam equals 0. Don't forget to say that my moments equals force times distance. And I've already calculated that where all my positive moments, which all my clockwise moments will be positive, minus all of the moments that are counterclockwise. So what I do now is I look to see how many forces are going to cause my beam to go clockwise. That force will push that and it'll make it go clockwise. So it's going to be that force as well as that force. This one will make it go counterclockwise. So I'm going to have two forces there. So here we go. First brackets is going to be this force, this downward force, the 300 newtons, causing my beam to want to pivot this way if I had to remove this and put it a pinned movable force. It is force 300 newtons times 2 meters, because it is 2 meters from the end. That is the sum of also that force there. That force is 346.41. How far is that from there? 2 plus 3 is 5. So those are all the forces going to cause my beam to want to rotate and have the turning effect on it in the clockwise motion. I now look at all the ones that are going to cause a counterclockwise or anti-clockwise motion. It is going to be my force of my right support, vertical, pushing it that way, times how far it is away. 2 plus 3 is 5, plus 8 is, almost said 6, 8. So 2 plus 3 is 5, 6, 7, 8. And let me work this out. So that's going to be 600. 346.41 times 5, 1732.05 minus FRV times 8. So obviously that's negative and that's together. Plus 600, 2332.05 minus 8 FRV. I'll take that to the other side. It becomes positive 8 FRV equals 2332.05 divided by 8. They cancel each other out. Divided by 8. (291.5), and it is all newtons. Making sure I haven't put any. There we go. So the force that this roller support is supporting that beam at upwards, because it's positive, is 291 newtons. What I'm going to do now is I'm now going to do a third step, which is solve the force horizontal and force vertical by, instead of doing a moment, I could do another moment calculation, but I won't actually then find the horizontal force. So I'm going to do the addition and subtraction of forces up and forces down. So let's look at horizontal first. Left and right forces. Technically, because this is imbalanced, the sum of all the forces to the right will equal sum of all the forces to the left will equal sum of the forces to the right. That will equal, I'll go to the other side, plus sum of the forces to the right minus sum of the forces to the left. Hence my part of this. How many forces do I have pushing to the right? Well, I don't know, because that's a pinned support. I don't know what the force is, so I'm going to assume it's a positive, which means it's going to the right. Therefore, this is force left horizontal. Any other forces pushing to the right? No. But I do have a force pushing to the left, which is my 200 kilonewtons here. Bring that over to the other side. It changes to a positive. Shows me that my force horizontal is going to be in that direction, balancing out the negative. So the left hand, force pushing to the left hand by that angled load of 400 newtons will create an opposite reaction in this pin here, this pin support here of positive 200. So that's my force left horizontal. Force left vertical also, because it's in equilibrium, the sum of my force downwards equals the sum of my force upwards. This maintains its positive nature. This one goes over to the other side and becomes negative sum of the force downward. Again, proving my positive and negative directions of my little diagram there. So I now look for all the forces pushing upwards. Well, I've got two. Those two are pushing upwards. So let me expand on this. What's pushing upwards? I have already solved this side, which is 291.5 plus, I don't know what that is. I'm trying to solve that. Minus the forces pushing down, which is 300, and also the downward force there, which is 346.41. So this would be spread out. It will be 291.5 plus force left vertical minus, well, let me add those two together, 346.41 plus the 300 down as well, 600, 646.41. I'll add those up. $291.5 minus 646.41 is obviously going to be a negative number, negative 354.91 newtons. Goes to the other side. Don't forget to say it's the unit newtons, and it's a positive, therefore it is upwards as well. So to prove that, I can do my little diagram. If it doesn't tell you to do that, to do a diagram, you don't have to. It just said calculate the reactions. I'm going to do it just to double check that my answers are correct. So let's have a look at this. I got my beam. Oh, my right hand support. Vertical is 291.5 newtons upwards. The left hand vertical support is 354.91 newtons upwards. My left horizontal is 200 in that direction. I've got this section here. It's 200 in the opposite direction, so that's balanced. It's got a force downwards, which is resolved into the perpendicular force of 346.41. And this one is 300 newtons. Don't forget to put the units in. So if I add up all the up versus the down, you can see left and right, 200 and 200 will cancel each other out. That plus that should equal that, that and that. So let's just say all the forces upwards, 354.91 plus 291.5, 646.41 newtons upwards. What's all the forces downwards? 300 plus that one there, 346.41, 646.41. So we know that's right. We know that's right. We know that's correct because the two cancel each other out there and there. And I can do this. Oh, that's it. There's all my forces being solved. So there we go. This sum can also be anywhere between 3, 4, 5, or even 6 marks, depending on the teacher. Guys, I hope that helps you. I hope it gives you some clarity. And I'll do one more. It's a bit more complicated. This was having 2 forces. My next question is going to be 3 forces. See you guys later.